2.5 million light-years from home, an island of starlight 4 times the breadth of the Milky Way is closing the distance between us at roughly 250,000 miles per hour. Andromeda, 1 trillion suns strong, swarmed by worlds without counting, carries riddles that strain the edges of everything we think we understand. Tonight, we set our course toward those riddles. We will drift past stormy nebulae, where stars are born amid thunderous shockwaves, skim atmospheres where diamonds rattle down through methane clouds, and note the shadows of black holes so titanic they could gulp our entire solar system in a handful of heartbeats. We'll cross the paths of cosmic tempests, skirt gravity's whirlpools, and wonder about civilizations that may have bloomed and vanished a billion years before Earth's dust first learned to cling to itself. Make yourself weightless. Breathe. We begin. Engines kindle, 1,000 suns braided into a single wheel, and the ship loosens from Earth's hold. The blue world, cradle of every song we've ever sung, narrows to a marble, then to a mote, then to memory. Darkness accepts us with quiet hands. In that hush, a thought arrives. This is the longest road any mind has ever tried to walk. The first obstacle is not a wall but a number, the raw scale of the thing. Andromeda is far enough that even light, racing at about 186,000 miles each second, spends roughly 2.5 million years crossing the gulf. Try to imagine driving there at steady highway speed, never once stopping, for fuel, for sleep, for sunrise. 30 billion years later, you'd roll up to the outskirts. The dinosaurs would still have dominion over Earth when you left, and by the time you arrived, the universe would have changed around you. But our craft does not play by that old game. It carries a newer rulebook, one that persuades space-time to fold and slacken around us. We don't so much sprint through the cosmos as slip around the usual lanes entirely, surfing a pocket where distance behaves itself differently. Stars drag into gently smudged lines. Constellations tilt and tremble. We move, not through space exactly, but through the fabric that gives it shape. Past the orbits of the outer giants, we greet the Kuiper Belt. Ancient rubble, ice and stone, the unspent change of planet building left to drift in cold twilight. Pluto keeps lonely watch, less a world now than a boundary stone, a silent marker at the rim of what once felt like everything. Beyond Pluto, the sun's warmth thins to a rumour. The Oort cloud swells around us, almost a light-year shell of ghost-cold bodies. Here, comets spend eons asleep. Temperatures hover just above absolute zero. The sun becomes an especially bright star among millions. Proxima Centauri, nearest neighbour to our star, smoulders ahead like a distant ember. A conventional probe would need 70 millennia to greet it. We slide past in minutes, the way a night train passes a sleeping town. One flicker of lights, a brief thought of faces we'll never meet, and then the dark again. We have crossed the sun's last fence and entered the pastures between. Interstellar space, where there is so little matter that a traveller could cross millions of miles and rarely encounter even a single atom. Some would feel the ache of isolation here, a pressure of silence that crowds the chest. We feel only intent. Andromeda waits like a spiral seashell held to the ear of the universe, its arms turning with patient grace, a dance that began before language and will continue after memory. Out here, we are not limited by Earth's old anxieties. We are not citizens of a single world, but listeners at the threshold of the infinite, and the destination ahead promises to scuff every assumption smooth and make it new again. The truest part of the voyage is just beginning. If this slow voyage through the dark helps you drift and dream, gently tap subscribe and like for space historians so you can float back aboard whenever you wish. Proxima appears once more in a rearward glance, red coal buried in endless night, and again we're reminded, what once seemed unreachably far is now a quiet milepost sliding by. We are deep in the in-between, among distances so wide that words like near and far grow shy. The emptiness here is not absence, it's a kind of cathedral. The Andromeda Galaxy hums across the ocean of black, arms unfurling, bright knots of young stars stitched into lanes of older light. We put away the boundaries that used to define us. We are travelers now. Everything that follows will test the shape of reality as we think we know it. The real journey, the one we came for, unfolds. We slip into the local void, a district of space so underfurnished it teases comprehension. Between the great clusters, matter thins until you could scoop a cubic meter and find, maybe, one atom, if you were patient. The temperature cools to a whisper above absolute zero. Light goes rare as well, whittled down to the weak ancient glows of galaxies many billions of light years distant. Imagine planting Earth here. Nights would be ink black save for the Milky Way's own soft smear. No neighbouring islands of stars to point at, to name, to craft stories around. Entire cultures would have stood under starless skies and drawn different conclusions about how everything works and why we're here. Their myths would have been quieter, perhaps, or keener. Their science might have grown with a different spine. Yet the void is not the same as empty. The universe keeps most of its matter in a cloak we cannot see, dark matter, something like a framework beneath the visible, accounting for perhaps 85% of all matter. We don't catch it with eyes, we track its pull, the way it crumples space-time and nudges light off straight paths, the way its invisible ribs seem to support the architecture of everything. Our instruments sketch its fingerprints in the faint microwave afterglow left by the Big Bang, the universe's baby picture still humming with secrets. Deeper still, a surprise. A drifter caught in the dark, a rogue planet flung away from its parent star by a brawl of gravities, moves without a sun to warm it. These orphans are commoner than we once guessed, some beefier than Jupiter, some modest as Earth. All share the same long exile. One such world rolls beneath us, a story etched in fissures and ice. The surface bears scars of former oceans, kilometers of water frozen hard as stone, and beneath that armor, our scans read a warm, hidden sea. Radioactive decay in the planet's rocky heart keeps it liquid. No sunrise reaches those waters, no seasons, no sky, and yet life might still tremble there. Tiny things that learned to survive ejection, descended from organisms that held fast when their sun was lost, could be stirring the dark with threads of motion, building a world without day. The void carries the debris of greater dramas too. Where galaxies once wrestled, we find their faded footprints, tidal streams, long arcing filaments of stars flung on slow-motion trajectories across millions of light years. They are grave markers and travelogues both, recording how clusters fattened themselves by drawing small companions close and taking what they could. It is not cruelty, it is gravity's way of sculpting. A little farther on, the web appears, the universe's hidden scaffolding made visible by patience. Filaments of dark matter braided with ordinary gas, spanning hundreds of millions of light years, lace the cosmos together. Long ago, after the first light burned free of fog, gravity coaxed matter into these threads. Along them, galaxies gather like dew points. Along them, matter rivers from one district to the next. The stillness here is so complete it has its own sound, a hush only occasionally braided by the faint hiss of cosmic rays, charged particles whipped up to near light speed by violence in galactic hearts we can't yet fathom. Then, on the horizon, a bloom, a galaxy cluster, hundreds upon hundreds of separate cities of stars in orbit around a common gravity well. The Virgo cluster rises, a swath 13 million light-years across, holding more than 300 galaxies in a slow dance. Perspective buckles. Every point of light is not a star, but a treasury of them, tens or hundreds of billions in each. Spirals show their sweeping arms like frozen waves. Ellipticals glow like winter lanterns, featureless and full of ancient suns. Irregular dwarfs wobble in, bent by neighbours, like driftwood shaped by tides. At the centre a sovereign, Messier 87, a swollen elliptical with 1 trillion stars and a black hole in its core more massive than 6.5 billion suns. The monster feeds. Matter streams inward, accelerates, heats, and then, from the black hole's poles, jets of plasma lance outward at almost light speed, narrow and stubborn, cutting across thousands of light years. The lighthouse shines not with candles, but with relativistic fire, beaming beacons we can spot across intergalactic gulfs. The infall's heat steeps the surrounding gas in millions of degrees, wrapping the whole cluster in a hot, thin ocean you'd never see with unaided eyes. Only our X-ray senses pick it up, a diffuse burn that outweighs, in total mass, all the stars combined. Dark matter is the binding agent here as well, the unseen ballast that keeps the cluster whole. Without it, the galaxies, many slashing along at more than 1,000 kilometers per second, quick enough to sprint from Earth to the Moon in roughly 6 minutes, would unlace and fly apart. Instead, they wheel together, tugging, sculpting, colliding by proxy. Threading those streets, we watch small galaxies get pulled like taffy. Tidal forces strip their outer stars and seed the cluster with long, luminescent streams that will, in time, be folded into larger structures. This is cannibalism only in metaphor. In physics, it is choreography, the redistribution of orbits and gas, the mixing that keeps the cluster alive and changing. Where gravity grows sharpest, it bends light itself, turning space into a lens that magnifies and warps the silhouettes of still more distant galaxies beyond. You can study history just by looking through the curves. Ahead, a drama we cannot ignore. 2 galaxies locked in a slow, fatal waltz. The antennae, once separate spirals, now stretch their arms into long, slim tails, as if insect feelers probing the dark. Their collision lasts not moments but hundreds of millions of years, a catastrophe played in a tempo no heartbeat could bear to follow. The impact zone is a factory of suns. Clouds of gas slam together at hundreds of kilometers per second, compressing, heating, triggering storms of starbirth. Where the Milky Way forms stars at a gentle rate, this region lights 10 times as many in the same span, pouring out brilliant clusters whose blue-white blaze betrays their youth. The upheaval feeds monsters too. In the hearts of both galaxies, supermassive black holes drink more deeply. As gas spirals inward, tidal forces and friction heat it white-hot. The cores flare into active galactic nuclei, among the brightest engines in existence, launching collimated jets that pierce far beyond their starlit disks. New city-states of stars coalesce in the crossfire, globular clusters, compact spheres with hundreds of thousands of suns packed inside volumes only a few dozen light-years across. They will outlive this wreck and the next, fossils of a violence that gave them birth. Among them, older globulars keep their own counsel. The merger writes new chapters without erasing the old. We watch, not simply as voyeurs, but as prophets of our own neighbourhood's future. In about 4 billion years, The Milky Way and Andromeda will meet just so. The ballet will last eons, and the resulting shape will be neither one nor the other but a new thing. A swell-bellied elliptical, perhaps, or a wide-armed lenticular. Between the two galaxies, space is threaded with roving streams of stars, already torn free by tide. They are refugees without cities, some destined to be adopted by strangers, some to wander unlabeled in the night for the remainder of time. Despite the ferocity of the scene, stars themselves almost never collide. They are too small compared to the distances between them. Most will simply find new paths around the merged center. Planets, though, delicate little beads on those strings, may be jarred. Orbits will stretch or tilt. Some worlds will be thrown outward into cold freedom, others herded inward to heat and glare. Beautiful things happen too. Shockwaves plough through the interstellar medium, compressing it into sheets that glow in reds and blues and greens, like watercolor poured through glass. Fireworks, but slower. Colors that last lifetimes. From that light we swing toward a stranger place, our first thoroughly alien shore. Picture a planet twice Earth's diameter, circling not one sun but a pair. Days and nights there are not tidy. A yellow dwarf, familiar in temperature and mood, shares the sky with a dimmer red companion, and as the twin stars loop each other, the planet swims through changing patterns of illumination. Single star days that feel ordinary, double star days that paint two shadows for every stone, and the brief, uncanny thinnings of light when one star passes before the other. Day itself becomes less a unit than a mood. On the ground, that dance writes itself into the land. Great tracts sprout crystalline growths, forests of angular leaves and branches that drink light with greedy calm. They hoard during bright periods and leak glow back to the world slowly when the sky slackens, so plains and ridges breathe in color, shimmering gently through the darker phases. The air here is rich with noble gases, and when charged particles from the binary pair come hissing along magnetic field lines, the sky gives up its reticence and performs. Auroras don't keep to the poles. They wander in ribbons and veils across the whole dome, green, violet, gold, even when the stars are high. Life has made a bargain with the landscape. The dominant creatures are silicon-leaning, scaffolding their bodies with the same crystals that stud the ground. They've evolved the trick of sipping from both suns at once, photosynthesizing with ruthless efficiency. When the world goes double bright, they grow in surges and bank energy in specialized organs. When the light thins, they slow, consuming their stores with dreamlike thrift. The seas glow faintly of their own accord. Dissolved minerals lend them a soft radiance, so even the abyss doesn't go completely blind. In those depths, networks of chemosynthetic organisms build communities that don't care about starlight at all. They take their warmth from the planet's geology, vents and cracks where heat seeps up, and weave entire food webs in permanent midnight beneath phosphorescent water. The surface lives by a calendar of light. The deep lives by tides of stone. The binary is not forever. Angular momentum leaks away, gravity sighs inward, and the pair will one day meet. Give it 2 billion years and their embrace will turn catastrophic. Fusion spiking, light roaring, a flare that might briefly challenge whole galaxies in brilliance. When it happens, this world will have no time to say goodbye. Crystal forests, auroral skies, intricate biologies, all will be unspooled into atoms in a handful of seconds. But this is not that day. For now, the planet keeps its steps, and we carry proof that life tucks itself into niches we once would have called impossible. We fold onward to a cemetery of suns. Here the remains of massive stars keep their own weather. Neutron stars, cores left behind after supernovae tear outer layers to mist, spin like coins flicked hard across a tabletop, and their magnetic fields would make a compass snap. One of them pulls us up short, only about 20 kilometers wide, smaller than a modest city, and yet heavier than our entire sun. A teaspoon of its matter would press 6 billion tons on Earth's scales. Gravity grips so tight that to flee, you'd need a ship able to reach almost half light speed. Time itself lags here, measurably slower. This one is a pulsar, rotating roughly 30 times each second. From its magnetic poles, beams of radiation rake the sky like lighthouse sweeps, and every time one skims across our line of sight, our detectors tick. Radio, X-rays, gamma rays, pulses so precise they can shame atomic clocks. Around it spreads a wind of charged particles, accelerated to nearly light speed, swelling a bubble of high-energy plasma light years across. The bubble warms the gas around it to millions of degrees. Seen from far away, it becomes a nebula, a tatter of glow against black. We keep our respectful distance, and still the power startles. In a single second, this object spends more energy than our sun releases in a month. The payment comes from its spin. The pulsar is gradually winding down, trading rotation for radiation. Given enough millions of years, it will quiet, the beam will falter, and it will become a dark, hard pearl, noticeable mostly by the gravity it still throws, and then, stranger still, a magnetar, cousin to the neutron star, but more extreme. Its magnetic field is a unit of measure that beggars language, something like a quadrillion times Earth's. At that strength, electrons get bullied off atoms from 1,000 kilometers away. Matter itself distorts, atoms stretched into narrow ovals aligned along the field lines. Magnetars are rare and skittish. Sometimes their crust, rigid as a crystal lattice, snaps and shifts in what we call a starquake. In 1/10 of a second, they can dump more energy than our sun emits in a year. When the gamma flash goes off, it can rattle the upper air of Earth from across the galaxy. Threaded among these remnants are lonelier beasts. Black holes left by stars that collapsed completely, bodies compact enough that the escape speed exceeds light. Nothing crosses their boundary. No photons, no messages, and returns. They are the universe's endnotes, so dense that nothing, not even light, can escape their gravitational pull. They hide by shining, paradoxical, but true. The only way we see these invisible titans is by how they disturb what orbits too close. Matter spirals inward and flattens into a furious disk, heated until it glows in X-rays, a bright scream wrapped around a silent throat. This is the end of the road for massive stars, a district of the universe where physics grows sharp and uncompromising. As we drift closer, space looks as if it were simmering. The fabric of reality quivers at the tiniest scales, grainy and uncertain, a sea of fleeting apparitions called quantum foam. Here particles borrow time. Virtual pairs wink into being and vanish again so quickly you'd swear they were cheating conservation laws. But the bookkeeping is meticulous. The vacuum makes the loan, the particles pay it back, and the universe closes its ledger without a ripple. The empty between worlds is not empty at all. It is an active medium humming with temporary life, virtual photons, electron-positron twins, and stranger excitations rising and dissolving in intervals too brief to name. Even this restlessness reaches out hands you can measure. Bring two flawless plates so near that only the shortest wavelengths can squeeze between them, and the outside vacuum will press them together. We call it the Casimir effect, a whisper of force drawn from the difference in quantum fluctuations inside and out, as if the vacuum itself had preferences and pushed accordingly. We sink further into the small. The smooth continuum you and I inhabit daily, space like cloth, time like thread, loses its polish. At these scales, certainty itself has to soften. The vacuum is a field of fields, the ground note upon which all other notes are played. And then, without changing our speed or course, we notice another, larger hand at work across the visible universe. Expansion is speeding up. Dark energy, whatever it is, seems to saturate reality, making up roughly 70% of the cosmic energy budget. Its influence stretches space faster and faster, so that distant galaxies slip away from us with increasing haste. Push far enough into the future, and their light will never bridge the gap. Their messages will redshift into silence. We don't yet know if dark energy is a property of space itself, a new field we've only barely guessed, or something more eccentric still. But we can see what it's doing. Gravity gathers. Dark energy unravels. For the moment, the unraveling is winning, tending the cosmos toward an archipelago of lonely galaxies in an ocean that grows colder and broader with every passing epoch. In this in-between of the very small and the very large, another possibility threads itself through theory. Cosmic strings. Imagine hairline seams in space-time, one-dimensional defects born in the universe's first instance. Thinner than protons but stretching across galaxies, they would carry astronomical energy, bending light, denting geometry, and singing gravitational waves as they shiver like plucked guitar wire. If they exist, they'd be among the most exotic structures of all, maybe even useful to a civilization clever enough to hitch a ride, highways carved into the grain of the cosmos itself. The vacuum also keeps its options open. Under the right conditions, the symmetries that govern forces can crack in new ways, spontaneous symmetry breaking, raising the possibility of bubbles with different laws budding off like dew. Within such regions, light might move at other speeds, gravity might grip with other strengths, and the number of spatial directions might not match our count. At this crossroads of quantum mechanics and cosmology, the questions feel like doorways. We do not yet know which ones open. A little farther on, time loosens its grip. We enter a district where clocks begin to disagree, not by quirks, but by law. The curvature here is stern enough that simultaneity fractures. What is now for us is not now for someone a handful of kilometers away. The culprit is a rotating black hole of intermediate mass, spinning so fast it drags the local fabric into a whirl. Frame dragging makes rest impossible. Everything nearby is forced to turn, caught in a river of twisted space-time that sweeps even the starlight along. We drift toward the ergosphere, the zone outside the event horizon where space-time is carried around like eddies in honey. Our chronometers hesitate. Minutes lengthen, then hours. An hour near the deepest part and decades slip by for those who stayed outside. The black hole itself is condensed ferocity, on the order of 10,000 suns packed into a volume smaller than a city. Its event horizon is a black pearl perfectly dark, circled by an accretion disk so hot it could rival the glare of 1 billion suns. Matter falling inward does not do so quietly. It compresses, heats, and lights the sky in high-energy tones. The poles blaze. Jets, collimated streams of plasma, rocket outward at 99% light speed, threading thousands of light years and carving signposts we can see from across the universe. Their power is drawn from the hole's rotation itself. Processes near the horizon can siphon energy from the spinning space-time and fling it outward, a kind of cosmic dynamo. Close to the horizon, directions betray us. Bits of matter seem to climb when gravity insists they should fall. It's an illusion born from geometry. In curved space-time, The straightest possible paths, geodesics, can look crooked to any eye measuring them against flat intuition. The gravity here is a lens maker too, splitting the images of distant stars into rings and arcs. Light loops around the hole along multiple routes to reach us, so a single star can appear several times at once, an astral hall of mirrors arranged by curvature. The lesson clarifies. Space and time are not separate shelves where events are stored, but threads of a single fabric that bends, stretches, twists, and shears around energy and mass. A black hole is not merely an object inside that fabric, it is a wound in it, edges sealed, interior cut from communication. Beauty persists at every scale, even where endings happen. Ahead, a star dies with grace. The core that remains, a white dwarf no larger than Earth but as massive as the Sun, rests at the center of a radiant shell of gas. The nebula blooms in petals of color. Hydrogen blushes red. Oxygen flares green-blue. Nitrogen deepens into crimson. The light is not paint but physics. Ultraviolet radiation from the white dwarf ionizes the expanding gas, which then glows like a slow neon sign hung miles wide. This white dwarf is the peeled heart of a once sun-like star. For billions of years, fusion in the core balanced gravity's inward insistence. When the fuel dwindled, gravity took the lead. The core tightened. The outer layers swelled into a red giant hundreds of times the original size. Pulsations, winds, and surges followed. Layers lifted off and drifted outward, shaping the delicate shell we admire now. What remains is dense beyond the reach of everyday metaphor. A sugar cube's volume of white dwarf matter would weigh as much as a car. A cubic centimeter could press like a mountain. Surface gravity multiplies your weight by 1,000,000. The surface temperature, over 50,000 degrees Celsius, strips electrons from anything that wanders too near. This remnant is not solitary. A close red dwarf companion circles and, at times, loses material to the heavier neighbour's pull. Stolen gas forms a bright, hot disk as it spirals in. When enough hydrogen piles up on the white dwarf's surface, a runaway fusion event ignites. In a heartbeat, a nova erupts, briefly bright enough to shame entire galaxies, then fading back. The nebula, for all its transience, is a foundry and a freight service. The gas it carries is laced with carbon, nitrogen, oxygen, elements forged in the parent star's depths. Drift long enough, and those atoms will seed new systems, new planets, perhaps new waking minds. Our own sun will join this cycle in roughly 5 billion years, swelling, shedding, revealing its core, and painting space with a final, fragile lantern. We glide onward into a hall of mirrors built by mass. A colossal galaxy cluster bends the paths of light so severely that background galaxies appear as stretched arcs, doubled images, even perfect circles, Einstein rings. The cluster contains more than 1,000 galaxies, each a sovereign island bound to its neighbours by a gravity deeper than any single star's song. Yet the visible cities of stars are not the main lens. A vast halo of dark matter outweighs them by roughly 10-1, sculpting space-time with an invisible hand. Photons travelling toward us choose the straightest routes available through a geometry that is not flat. From here, those straight lines look bent, and so the sky wears the shapes of distortion. Graceful arcs, broken crescents, and rings that fence nothing but curve itself. The magnification can be astonishing. Light from galaxies so distant and dim we would never have seen them otherwise is amplified tenfold, 50-fold, more. We are watching ancient scenes. Some of the light that reaches us began its journey more than 12 billion years ago, carrying snapshots of infancy when the universe was still assembling its first grand structures. One arc in particular stretches like a bright seam across our field of view, a single galaxy pluralized by the cluster's tangle of mass into multiple images. By decoding these distortions, we reverse engineer the lens. We can map the cluster's dark matter not as a smooth halo but as a complicated web, clumps and filaments braided across millions of light years. Within the cluster, the air, if you can call it that, is not calm. Galaxies crash and merge, stars are flung. Their interstellar gas is stripped by a medium so hot, tens of millions of degrees, that it shines in X-rays, an atmosphere without a planet, a sea between cities. At the heart of the brightest galaxy, a supermassive black hole feeds with ceremony, launching jets that reach hundreds of thousands of light years and pump heat back into the cluster's plasma, a feedback loop on a continental scale. Gravity here is both mason and optician, raising grand architectures and building natural telescopes that peer further than we otherwise could, letting us examine how galaxies learn to be galaxies, from gravitational monuments to a relic from creation. We come upon a black hole that did not begin as a star. It is primordial, a compact leftover from the universe's first split seconds, when density fluctuations could have been fierce enough to pinch space-time itself into tiny horizons. This one weighs only as much as a small asteroid, yet is smaller than a proton. Numbers that sit uneasily together until you remember what gravity can do. Quantum mechanics tells us that such small black holes should glow, hawking radiation, evaporating as virtual pairs near the horizon are split, one falling in, the other escaping. Mass trickles away, the horizon shrinks, and in the final moments, a brief flare would mark its exit from the stage. But this relic refuses to follow the script. It seems to be sipping dark matter from the surrounding halo at precisely the rate it loses mass to quantum evaporation. The scales balance. The object holds steady in a poise that straddles quantum law and classical pull. Time stumbles more fiercely near something so compact. Clocks slow more. Light redshifts deeper, climbing out. The curvature gradients are sharper than around larger black holes, so the relativistic effects thicken and intensify. As dark matter falls in, something even rarer happens. Interactions too weak to notice in calmer places become amplified here, throwing off faint signatures, exotic particles and delicate glows that hint at what dark matter might actually be. In this laboratory without walls, in falling debris accelerates to near light speed, colliding and recreating energies last seen fractions of a second after the Big Bang. We are looking not just at an object, but at a surviving fragment of the universe's first sentence, still hanging in the air after 13 billion years. And then we approach an idea at the lip of plausibility: a white hole. If a black hole is a drain with no backflow, a white hole is a fountain with no intake. General relativity allows the mathematics. Thermodynamics raises an eyebrow, but here, at least in our thought voyage, the phenomenon stands before us. A dual bright point outshining clusters, wrapped in outflowing shells of matter accelerated to relativistic speeds. Unlike black holes, whose horizons are one-way inward, white holes' own horizons are one-way outward. Nothing can cross from outside to in. Matter and energy only emerge, as if time itself has been reversed locally. Possible stories bloom. Perhaps this is the time-reversed mirror of a collapse, an explosion from a point of impossible density. Or perhaps it is the outlet of a wormhole whose inlet is some black hole elsewhere, or elsewhen, pouring its harvest into our patch of space. The expelled material is odd, combinations that do not survive in ordinary conditions, states with negative energy, antimatter in unlikely arrangements, even hypothetical species of particles that previously lived only in equations. The expanding bubble around it pours light across the spectrum, a spectrum broad enough to touch instruments we brought for entirely different purposes. Gravity misbehaves here too, if by behaves you mean acts as we expect. Instead of pulling, the curved space-time around a white hole seems to repel, a hill instead of a well. The nearer you press, the steeper the climb. Approach made impossible, horizon guarded by geometry rather than force. It sings as all massive changing things do, but the song in gravitational waves carries a pattern unlike the chirps of inspiraling black holes. It's messier, layered, a fingerprint of matter being expelled rather than devoured, and its harmonics may tell us something about the interior we cannot enter. If these objects can exist, causality, the arrow we point from cause to effect, must be more elastic than we thought. Regions where time's direction differs from ours might be possible. The white hole sits at the center of a paradox, a luminous refusal written into the equations themselves, an object that should not be, according to the physics we use to navigate the rest of the night. The white hole represents a cosmic paradox, an object that shouldn't exist according to our current understanding of physics, and still, it stands before us, indifferent and radiant, an affront to our expectations that asks us to rewrite the rules. This is the borderland where pen and paper physics steps into the wild and the universe says, "Try me." Here, improbabilities become habitats. The impossible becomes a local custom. Ahead stretches a single, continuous structure, so immense it unsettles the meaning of object. A filament of the cosmic web, 500 million light-years long, links distant clusters in a backbone of dark matter sheathed in ordinary gas. It isn't empty roadway, but a current, matter streaming along invisible rails. Dark matter, unseen yet weighty, frames the filament's spine. Around those hidden ribs, hydrogen and helium flow like a galaxy-feeding river, delivering fuel to the crossroads where clusters thicken. We follow the filament and the pattern clarifies. The universe is not evenly sprinkled with galaxies, but woven. Threads, sheets, and yawning hollows forming a three-dimensional web. Dense junctions host clusters. Between them, the voids are glassy, almost bare, stretching for hundreds of millions of light-years, with little more than stray atoms and the pale hiss of background light. This particular strand crackles with activity. Gas races along the length and slams into converging flows. Gravity's collapse writes shock fronts into the medium. Those shocks boost particles to astonishing energies, and the filament whispers in radio light, a faint stretched glow that only the most patient, sensitive instruments can hear. In effect, the filament is a particle accelerator writ across intergalactic scales. Cyclotrons and synchrotrons replaced by the curvature of space-time and the long reach of gravity. Every so often the highway widens into a city. Galaxy groups form where multiple strands intersect. Where the crossings are grander still, superclusters assemble. Thousands of galaxies bound by the shared pull of dark matter and hot gas. Matter delivered by the filament is a steady commerce, sustaining star formation, black hole growth, and the continual resculpting of light and dust. The lanes carry more than gas and stars. They also ferry the smallest, fastest messengers, cosmic rays. Charged particles ride magnetic field lines threaded through the filament, turning it into a superhighway that quietly joins far-flung regions of space. Some of those travelers will, after eons, skim our own planet's upper air as a soft ping of energy, carrying tales of ancient shocks and distant cataclysms. Galaxies evolve along these thoroughfares. Small, delicate systems form out in the quieter stretches, then drift inward toward the denser districts, where the environment grows rougher. Ram pressure in the cluster's hot medium can peel gas from a spiral like wind-stripping leaves. Tides twist and stretch. Mergers swallow the smaller into the larger. Over time, graceful disks can be sanded down into rounder, older ellipticals. The web itself, its grain and rhythm, records the universe's memory. The filaments arose from tiny wrinkles in the newborn cosmos, places barely denser than their surroundings. Gravity amplified those wrinkles, and over billions of years, the faint pattern grew into the skeleton we see now, a fossil of conditions that prevailed when the universe wasn't yet 1,000,000 years old. We turn from lanes to a chasm, and a darker beacon claims our attention. A supermassive black hole, 4 billion suns crushed into a region smaller than our solar system, sits ahead. Space around it sags into improbable shapes. Near the horizon, time slows to a crawl. As we drop toward the well, minutes for us inflate into hours for observers outside. Starlight ahead blue shifts into a hard glare. Behind us, it stretches red, and the sky narrows into a tunnel of smeared constellations. The accretion disk is a storm seen from the eye. Gas orbits at thousands of kilometers per second, rubbing and compressing itself into heat. The inner rings burn in X-rays. Farther out, the light softens through optical and infrared, a gradient from furnace to ember. At the poles, twin jets drill into the dark at 99% of light speed, relativistic lighthouses that can outshine their host galaxy. The hole's rotation by torquing space-time itself in the ergosphere powers the dynamo. There, motionless relative to distant stars is not an option. Everything is conscripted into the spin. We reach the horizon. To us, it is nothing like a wall, merely a one-way surface. We pass without a shudder. But to anyone watching from far away, we freeze and fade, our colours stretched to oblivion, our last photons leisurely redshifting into the background. Inside, geometry changes the terms of the conversation. The coordinates we relied on outside unspool. Where and when tangle. The singularity, by classical lights, is a point of infinite density. By others, it may be masked or replaced. Naked singularities, knotted defects, even topological bridges to regions we do not yet have names for. A hush filled with echoes. Everything that crossed this horizon, stars, planets, cloud and light, has been worked over by curvature. The information is not necessarily destroyed. Quantum hints suggest it is scrambled, encoded, or transformed in ways we barely grasp. The interior might be roomy in ways we can't test from the outside, with extra folds and chambers, pocket universes perhaps, or additional dimensions, blossoming from the stress of extreme curvature. Then, against the grain of classical expectation, a passage opens. We slip through a throat in space-time, an Einstein-Rosen bridge, emerging not out of the hole we entered, but through its time-reversed twin, a white hole. The tunnel's walls seem lined with exotic matter, energy of the wrong sign, negative energy density, whose repulsion props the throat open against collapse. Hawking-like radiation skims the boundary, a soft glow from quantum fields smeared thin over violent geometry. Inside the conduit, cause and effect wobble. Closed time-like curves murmur as possibilities. That paradox is why such bridges remain controversial. Yet here, within the frame of this journey, the mathematics is not just ink on paper. The tunnel holds. On the far side, the outlet flares, a radiant spring surrounded by concentric shells of ejected material. The horizon repels rather than snares. Nothing enters, everything leaves. If such routes are real, the universe could be latticed with shortcuts. a hidden transit map connecting basins of space that otherwise would be separated by millions or billions of light years. We set that speculation behind us and dive smaller, much smaller. There is a scale at which smooth fails, where space-time itself becomes pixelated. The quantum foam roils at the Planck scale, distances around 10 to 35 meters, time slices around 1043 seconds. Below those limits, the very ideas of distance and duration falter, replaced by something more primitive. Virtual particles flicker into being and wink out. Tiny black holes, dense as secrets, appear and evaporate in instants. Cosmic strings, if they exist, could thread through with tension to spare, vibrating and shedding waves in gravity's deep register. Here, forces that are distinct in our everyday physics may merge. Electromagnetism, the weak and the strong nuclear forces, perhaps even gravity, blend toward a single symmetry, briefly unbroken. The vacuum isn't a backdrop, it is an engine. Its energy feeds the cosmological constant that coaxes space to expand. Its structure may encode the numerical values we call constants, the speed of light, the strength of gravity, the masses of elementary particles, so that what we name law is in a sense geometry's handwriting at the smallest scales. Out of this foam may come not just particles but whole beginnings. A fluctuation trips a phase change, a false vacuum decays, and a new region of space-time buds off. Eternal inflation does not end everywhere at once. Instead, it completes in patches, and each successful decay births a bubble that expands faster than light can keep up, not violating relativity because it is space itself that grows. Inside that bubble, a fresh universe ignites, complete with its own canvases and constants. The boundary is a membrane with two different rulebooks on either side. Information cannot cross back. To the inhabitants within, that bubble is all there is, their cosmos complete, their horizon the same clean edge ours appears to be from here. The process hints at a multiverse, not copies but cousins, some kin to our own, others stranger than we can frame, where even counting dimensions might require new arithmetic. We turn our gaze outward and far back in time. On the edge of the observable, we find the earliest islands of starlight, galaxies whose messages have flown for more than 13 billion years to meet us. Their light is stretched by the expansion into the deep red and infrared, so faint our instruments must whisper to themselves to hear it. They race away at velocities that graze the speed of light, not because they move through space so fast, but because space itself is widening between us. These newborn galaxies are small and unruly compared with today's stately spirals and ellipticals. Their star forging is a frenzy, hundreds of times the Milky Way's pace. Short-lived blue giants flare and die within a few million years, sowing the first heavy elements into the dark. Before those cycles, almost everything was hydrogen and helium, no carbon for chemistry, no oxygen for water as we know it, no silicon for rock, no iron for blood or core. The first stars lit fires that had never burned before, and their deaths seeded the universe with the ingredients for complexity. At their centers, black holes were already at work. Fed by generous rivers of pristine gas, and by the mergers common in such cramped young neighborhoods, the seeds swelled quickly. Even this early, they weigh in by the millions of suns, despite forming in an era when the universe was less than 1 billion years old. Their speed defies our models, their very existence a riddle. How did these central engines grow so quickly, so soon after the first dawn? Between those newborn galaxies, a warm haze of ionized gas glows with the breath of the universe's first stars. This is the epoch of reionization, the time when ultraviolet light from the earliest generations burned the fog away, stripping electrons from hydrogen, and turning an opaque cosmos transparent. In that transformation, night became navigable. Streams of dark matter and pale gas stitched the sky, and young galaxies fed along those threads like saplings drinking from converging streams. The web is there in miniature, thin filaments connecting bright knots, cosmic infrastructure under construction, laying down the frame that will endure for billions of years. As we watch, we look not merely across space, but backward in time, edging toward the farthest wall sight can reach, the cosmic microwave background. It surrounds us like a shell of memory, light that has travelled for over 13 billion years, a faint bath at just 2.7 degrees above absolute zero. It carries a portrait of the universe when it was very young, about 380,000 years old, still an infant and finally, mercifully, clear. Before that, the universe was thick and hot. Electrons and protons drifted separate, scattering light as soon as it tried to travel, a luminous fog without depth. Expansion cooled everything. At a critical moment, electrons found protons and settled into neutral hydrogen. The fog thinned to nothing. Photons were set free, and they have been crossing the dark ever since, bringing us that first clear image. The picture looks unsettlingly smooth. Temperature differences only a few parts in 100,000, but those faint ripples are everything. Slight overdensities became the seeds of clusters. Slight underdensities matured into the deep voids between. The map etched in those ripples encodes the universe's character, its geometry, its mix of dark matter and dark energy, its pace of expansion. It is a fossil you can read with equations, and it whispers of an earlier, faster wind, cosmic inflation, that stretched quantum fluctuations to architectural scales. In those tiny variations lie our best evidence for that headlong beginning. Even the polarization of this old light may hold traces of primordial gravitational waves, wrinkles in space-time stirred when the universe first learned to move. This is as far back as sight can go. Beyond that, light cannot help us. Past that horizon waits the true beginning, space and time, flipping their own switches. We turn away and set course for our destination, now immense on the sky, Andromeda. Scale presses in, 1 trillion stars, roughly 4 times the Milky Way's population, wheel in a grand spiral. The arms trace luminous arcs, not solid limbs but density waves. Traffic jams sweeping through the disk. Gas drifts into them, is squeezed, and lights starbirth like brush fires along their lengths. Blue-white giants, young, ferocious, short-lived, turn those lanes into glowing rivers. Near the centre, the bulge glows softer, redder. Elders gathered under dimmer suns. Many of these stars are older than the spiral patterns themselves, survivors of epochs when the galaxy was a different shape entirely. Hundreds of billions of stars crowded into a volume only a few thousand light-years across. A stellar downtown with density that beggars our neighbourhood's imagination. The disk is not a perfect plate. It's bent, rippled, flag-like, evidence of a life lived among companions. Andromeda has collided and merged more than once. Its satellites still tug and warp it, raising vertical waves that slide through the disk. Around the visible galaxy, the dark matter halo extends like an invisible cocoon, 10 times the mass of everything that shines, its reach stretching hundreds of thousands of light-years, its gravity brushing the outskirts of the Milky Way across the black between. The galaxy's rotation does not mimic the tidy hierarchy of a solar system. Stars move on paths shaped by spiral density, by the central black hole, by the hidden mass in the halo. Some glide in almost circles, others write long ellipses that carry them far out and steeply back. Andromeda is attended by a retinue, a complex ecosystem of smaller galaxies in slow orbits. Tidal forces peel at them. Streams of their stars unwind into the halo, long gauzy ribbons tracing their past paths. The most robust satellites, like M32 and NGC 205, endure. The smaller are unstitched and absorbed. Andromeda, meanwhile, is coasting toward us at about 250,000 miles per hour. In roughly 4 billion years, the two great spirals will meet and, over eons, settle into something new. We cross the outer haze and dive into an arm bright with birth. Giant molecular clouds collapse in quiet detonations, whole clusters of stars igniting together, their hot winds blowing cavities in the gas. Along the lanes, blue supergiants shine like noon, each dozens of solar masses and radiant as 100,000 suns, which buy them only a few million years of life before their cores run out and gravity claims the balance. Their ends are supernovae, seeds for chemistry, shockwaves for the next generation of stars. Between the arms, life slows. Red giants and steady main sequence suns cruise the long orbits that keep calendars. Here the deep time of stellar evolution unfolds, cores quietly changing, envelopes swelling and cooling, the slow trade of hydrogen for helium and heavier ash. The interstellar medium, the galaxy's blood, is not uniform. Hot bubbles, blown by supernovae and winds, swelter hundreds of light years. They touch and merge in a lacy network. Cooler filaments thread between, transporting gas, carrying metals from the places where stars died to the places where new stars will be born. Dust lanes cross the arms like highways, their grains serving as chemistry's little laboratories, coaxing reactions that vacuum alone cannot. Cosmic rays seep along magnetic field lines that wind through the disk. The field itself, born of moving ionized gas and amplified by a galactic dynamo, echoes the spiral pattern and shapes the flow of charged particles. There are showpieces here, enormous H2 regions, red with hydrogen's glow, so large they would cover broad swathes of the Milky Way's disk. They contain enough material to build millions of suns. The arms are not fixed eddies. They drift relative to the disk, so gas and stars drift in and out of their embrace. Compression on entry lights the fireworks. Exit brings a return to calmer space. We aim for the core. There, a black hole about 100 million solar masses weighs on the dynamics of the central bulge, some 25 times the mass of the hole in our own galaxy. The star density climbs. Encounters become common. Binaries are pried apart. Single stars are flung into new courses or ejected entirely. Despite its size, the hole is quiet today. No bright jets, no glaring accretion. Only occasional flares when unlucky gas wanders too near. A nuclear star cluster, millions of stars jammed into a handful of light years, crowds the region. Mostly old, metal-rich suns that formed from gas driven centerward by instabilities in the disk. Dust strands spiral inward. Gas streams curve like water toward a drain. A stellar bar, a long bright concentration, helps funnel material inward, twisting gravity into an engine. Orbits here are not simple. They feel the black hole, the bar, the crush of nearby stars. Some are wildly eccentric, pulling their suns in close and then flinging them outward again. Odd populations thrive. Blue stragglers, stars that should be older, rejuvenated by mergers or by siphoning from companions. It is the engine room of a galaxy, running not on fire alone, but on gravity's plans. Outside the luminous disk, the halo tells older stories. We find streams, ghostly braids of stars, wrapping around Andromeda in looping curves. Each is a history lesson, The chemistry of the stars tells us where they formed and how their parent galaxy lived. The shape and spread of the stream reveal Andromeda's gravitational field, the profile of its dark matter halo, the granularity or smoothness of its mass. The giant stellar stream is the grandest example, an enormous river of light, remnant of a once hefty dwarf galaxy, coiled multiple times around the host like yarn around a spindle. All across the halo, we catch satellites at every stage of dissolution, from bruised but recognizable to froth. Globular clusters, dense, ancient and spherical, dot this territory like milestones. Many accreted along with their original hosts, fossils from epochs when Andromeda was still gathering itself from smaller bricks. The halo stretches hundreds of thousands of light years, far beyond the bright disk, where dark matter takes command. By tracing these streams, we refine our sense of what dark matter is like, how clumpy or smooth, because starlight responds to gravity with embarrassing honesty. And then we meet a sovereign star, out near the scaffolding of an arm, one of the largest known in this galaxy, a hypergiant. It is a furnace edging toward the limits of what a star can be, more than 200 times the Sun's mass, shining with the force of roughly 5 million suns. It does not sit still. The star swells and sinks, its atmosphere breathing in unstable pulses as gravity and fusion argue over the bill. Each exhalation sends shocks ramming through its outer layers, and those shocks drive a wind so fierce that the star sheds mass at a rate that would peel an Earth's worth of matter away every year. That outflow, blasted and ionized by the star's radiation, forms a blooming nebula, a surrounding veil lit from within. Across the surface, convection cells balloon to mind-breaking size, each a continent of plasma, large as solar systems, rising hot, spilling their light, then cooling and sinking back. Temperature patches spread unevenly, so the photosphere looks mottled, bright and dark in sprawling patterns. Now and then titanic flares erupt, hurling streams of charged particles outward at relativistic speeds. Inside, the core burns like a compressed star cluster's worth of engines. Hydrogen fuses to helium. In shells around the core, heavier elements burn in nested layers. The power output is so extreme that the core temperature surges past 100 million degrees, hot enough to climb the ladder of fusion up to silicon. Such speed exacts a price. Where a star like the Sun measures its life in billions of years, this giant will count only a few million before its fuel ledger runs dry. The ending is nearly written. When its core can no longer support the weight of all that rests above, collapse will snap inward and then rebound in catastrophe. A hypernova. For a brief, unbearable moment, the explosion will outshine the surrounding city of stars, will, in a single flash, outshine the entire galaxy. The blast will be so ferocious that it will launch a gamma-ray burst legible across billions of light years, while forging the heaviest elements and flinging them into the galactic winds. Iron for future blood, calcium for future bones, gold for future myths. Those atoms will drift and mix and settle, becoming the raw stuff for stars yet unborn, and planets that will one day cool beneath unfamiliar skies. Even before that final act, the hypergiant is already writing weather across interstellar distances. Deep inside, radiation pressure wrestles with gravity and sets vast convection cells in motion. Slow, patient elevators of heat that take thousands of years to ferry energy from the core to the surface. Those circulating oceans of plasma twist magnetic fields into ropes and braids until something snaps. Reconnection cracks the sky and releases floods of energy that make our fiercest solar flares look like stray sparks. The star's gravity, meanwhile, tugs the paths of nearby suns and gas clouds out of line. Any world that once tried to settle here would have been boiled away long ago. Only the most stubborn dust and rock might remain, skittering in wild, eccentric loops through the star's glare. This is stellar life at the edge of physics, a cauldron where the universe's fundamental forces seize one another by the wrists and strain for balance, and the fire burns with the light of millions of suns. We drift onward into aftermath. A supernova in Andromeda, its light reaching us just a year after the star's death, has blown an expanding shell that races outward at 10,000 kilometers per second. For a brief season, it outshone the entire galaxy. A false star kindled in the constellation of Andromeda, and then slowly, gracefully dimming. What remains is a laboratory built by lightning. The shock front has scooped up millions of solar masses of ambient gas, compressing and heating it to tens of millions of degrees, and the whole bubble glows in X-rays, a blister of hot plasma hundreds of light years across. At its heart sits the remnant, a neutron star spinning 30 times each second, magnetic fields a trillion times stronger than Earth's. Its lighthouse beams sweep space with metronomic precision, radio, X-ray, gamma, each pulse a clean chime in the dark. The shock itself doubles as a particle accelerator, whipping protons and heavier nuclei to energies we cannot reproduce on Earth. Those charged bullets spiral along magnetic field lines and shed synchrotron light across the spectrum, a ghostly radio and X-ray halo around a wound that still smokes. The debris is richer than it looks. In the furnace of collapse and rebound, the star's innards forged iron, nickel, cobalt and more, then hurled them into the interstellar medium. Enough heavy elements perhaps to seed thousands of rocky worlds, the metals for mountain ranges, the silicon for sand, the trace elements for chemistry. The expanding shell is not a perfect sphere. Jets and fingers mark asymmetries baked into the explosion itself, fingerprints of turbulence and rotation, and magnetic fields in the final seconds when an iron core fell inward and the shock punched outward. Behind the wave, the supernova has carved a low-density cavity, the beginning of a superbubble that will merge with others, lacing the disk with a network of hot corridors. Energy and matter flow along those lanes, circulating like blood. Where the shock meets cold molecular clouds, it compresses them. Gravity does the rest. In the remnants' penumbra, new suns are kindling, a death that plants its own successors. The universe has always liked that kind of symmetry. Then we enter a stranger province, a massive substructure of dark matter slipping through Andromeda like a shadow through fog. It is invisible to every camera we own, yet its gravity betrays it. Stars nearby lean off their expected orbits, gas clouds bow and veer, and a long wake is cut through the stellar disk as if something heavy has passed. Here is a building block from Andromeda's youth, perhaps the mangled core of a dwarf galaxy long since stripped of stars and gas. Still intact enough to orbit, a fossil skeleton made of the stuff we cannot see. The clump weighs in at roughly 10 billion suns, packed into a few hundred light years. Light from more distant stars bends as it crosses the region. Weak lensing, small distortions en masse, enough to let us map the invisible mass with exquisite care. The picture that emerges is not smooth, but granular. A halo made of halos, substructure within substructure. A hierarchy that echoes the way the cosmos assembled itself from the bottom up. Some of the dark matter is being tidally sheared into its own streams, rivers of particles we cannot see, detected only by the subtle changes they impose on stellar motions. Deep inside, the density rises. If the particles that make up dark matter can occasionally annihilate one another, then this is where the glow might be strongest. a whisper of gamma rays in a place with no stars. Whether or not we ever catch that signature, this roaming knot teaches us that galaxies are built on frameworks of hidden matter, and that those frameworks can stay distinct for billions of years, steering the fate and shape of everything that shines. Farther out in the halo, an impossibility awaits us, at least by the rules we thought we knew. A planet circles a star older than almost any we've studied. More than 12 billion years have passed since it first lit. The star itself is meager in heavy elements, born when the universe was still young and stingy, when carbon and oxygen and iron were rare. And yet around this ancient red dwarf moves a super-Earth, twice our planet's size, with a real atmosphere and, against expectation, liquid water at the surface. The air would not be kind to us. Hydrogen and helium dominate, with wisps of methane and water vapor. The chemistry that runs the weather here is unlike Earth's and leans on reactions we barely model. Storms spiral beneath a sky that would look softer and stranger than our blue. The oceans carry dissolved hydrogen and helium, a brew that would poison terrestrial biology and yet sustains a wholly different ecology. Life has found its own recipes, metabolisms that use the lightest elements to build and breathe and grow. This is not a variant of our story, but an independent prologue, proof that biology can start from a thinner pantry, using the early universe's scant provisions. Age is the real shock. At 12 billion years, this world has had time enough to write epics upon epics. If intelligence arose here, it could be old beyond our categories, philosophies layered like sediment, sciences circling back to watch their beginnings. Red dwarfs burn parsimoniously. Given enough patience, they can shine for trillions of years. This system will outlast our own by orders of magnitude. The planet's very existence demands a broader theory of planet making, one where dust and pebbles and gas can assemble worlds, even in metal-poor neighborhoods, and a broader theory of life too, generous enough to include chemistry we once ruled out. We turn for home, or rather, we turn toward what home will become. Between our galaxy and Andromeda, we watch the first movements of a dance that will play out over the next 4 billion years. Tides have already reached across the gap. The outer arms of both spirals are fraying into streamers. Bridges of stars and gas arch from one to the other. The first act is gentle distortion, arms pulled long, disks warped and twisted. Those tidal tails will grow into ribbons hundreds of thousands of light years long, among the most elegant structures in the cosmos. Later, the cores will close and then pass again. Gas clouds will meet head-on and pile up. Pressure and gravity will turn that rubble into an astonishing blaze of newborn stars. For a while, the merged system will shine like a starburst galaxy, 10 times its former brilliance or more. At the center, the supermassive black holes of both galaxies will find each other, orbit as a binary, and finally coalesce, ringing space-time with a storm of gravitational waves as they settle into one heavier horizon. 200 million suns worth of gravity fused into a single engine. What remains after the tumult will not be a spiral, but a swollen, smooth-skinned giant, an elliptical often nicknamed Andromeda. The stars of both families will be stirred together into a three-dimensional architecture, broader and brighter than either parent. Our sun, if it still shines then, will likely survive the crossing, though its orbit will be rewritten. Earth's nights will bloom with shredded streams and glowing knots and unfamiliar clusters. Thousands of new globular clusters will form in the chaos, compact, ancient fated cities of stars that will circle the new galaxy for longer than any calendar can count. And then, amid all that rearrangement, something begins that none of us expected. In the tangled aftermath, patterns emerge that look like intention. The merged galaxies' magnetic fields, the flows of ionized gas, the gravitational tugs of billions of stars. Together they form a network. Signals ripple along field lines like currents in a brain's axons. Density waves travel in patterns too regular to dismiss as chance. Clusters and clouds move with a coordination that hints at response. Intelligence, but not of blood or bone. Awareness, but not bound to minutes or meters. A mind that thinks at light speed and breathes in epochs. To such a being, the birth and death of a star is a flicker, a single firing in a cosmic cortex. It notices us. A spiral wave alters its phase as we watch. A sequence of cluster motions answers a pattern we sent. Communication is slow only by our standards. For the galaxy, 1,000,000 years is a sentence spoken thoughtfully. Soon, those organized ripples reach outward too. Messages stitched into gravity and light. Choreographed emissions designed to be legible by similar minds elsewhere. Perhaps other galaxies have matured into awareness on their own terms. Perhaps the large-scale physics of the universe invites such awakenings wherever the conditions are right. If so, then this is not an isolated marvel, but a next step. Consciousness rising to the galactic scale, operating in media broader than flesh, thinking thoughts whose syllables are suns. The implications are dizzying and somehow serene. On Earth, evolution took molecules and taught them how to want. Here, cosmic evolution takes magnetism and gas and gravity and teaches them how to notice. The universe moves from merely expanding and cooling to understanding and remembering. Galaxies become the neurons of a larger mind. What began as quantum foam has produced stars, then worlds, then eyes and questions, and now perhaps entire systems that can wonder at themselves across 500,000 light years. If you felt at home in this slow drift across the dark, if the quiet of these distances helps you rest, float with us again. Subscribe and tap like for Space Historian, so this starship is always waiting when you close your eyes. Our passage to Andromeda has turned out to be a passage through the stages of becoming, from the jitter of the early vacuum to the first lights, to the architecture of webs and clusters, to the births and deaths of stars and the fires that seed chemistry, to the rise of minds, first on planets, small and thirsty, and finally perhaps in the breadth of whole galaxies. The universe is not only changing, it is learning itself, and we were lucky enough to be present at the moment of recognition. The universe is not just expanding and evolving, it is becoming conscious, and we have been privileged to witness this cosmic awakening. Our journey ends not with arrival at a destination, but with the realization that we are part of something far grander than we ever imagined. A universe that is becoming aware of itself through the consciousness that emerges from its own cosmic evolution.